That is, if f of z is analytic and mod of f of z is constant, prove that f of z is constant. So let's prove this. It is given f of z is analytic. So let's say f of z is equal to u plus iv. And so since it is analytic, we know that ux is equal to vy and ui is equal to minus vx. So that's, and it's also given if mod of f of z is constant. So I say mod of f of z is constant, let's see as c. So on the basis of this, I can write that mod of f of z is nothing but under root of u square plus v square, that is equal to c. Therefore u square plus v square, that is equal to c square. Name as equation number 1. Let's differentiate this. So first we'll be partially differentiating 1 with respect to x. So this comes 2u ux 2v vx, that is equal to 0, which gives me u ux v vx is equal to 0. Now when you differentiate, again same. So I say partially differentiate 1 with respect to y. So I get here ui plus vvy, this is v, that is equal to 0. So let's name this equation as 2, this equation as 3. Now on this 2 equation, as I have f of z is analytic, I just change this equation. See, again what we want to prove f of z is constant. That means indirectly, if we prove ux, vx, ui, vy to be 0, I can say that u and v are that function whose differentiation is 0, and that's why I can say f of z is nothing but a constant whose differentiation is 0. So that means we just need to prove ux, vx, ui and vy as 0. So I change my equation number 2, that is to total u. So I can write, for changing with 2 and 3 simultaneously, we can get that my ux is 0, and similarly we can say that vx 0. So let's first check whether we can get a ux as 0 or not. So what I do, in equation number 2, I make this whole equation in u form. So I can write ux as it is. In the place of vx, I can write minus ui. So that comes minus v ui, and that is equal to 0. So this equation I have got. And second, again I can make whole equation as in u. So u ui, so I just write here u ui, so that is in plus. The second is v vy, but vy I can write as ux. So v ux, and that is equal to 0. So if you want to solve and simultaneously, so that means obviously we want to eliminate some terms. So I can say here that for eliminating ui, what I need to do, I need to multiply first equation by u and second equation by v, and hence I can eliminate ui. So I say for eliminating ui, you say u square plus v square ux. So I eliminated this because when you multiply u, that becomes u square. Here multiplication of v, that becomes square, and that is equal to 0. So therefore you can say my ux is equal to 0. Similarly, as ux is 0, I can say my vx will be 0, my vy will be 0, and ui will be 0. So as all these 4 terms are 0, so we can easily say that as these 4 terms are 0, that means f dash of z is nothing but, if you say ux plus I vx, and that came to be 0. So if f dash of z is 0, so it's damn sure we can easily say that therefore f of z is constant. If f of z is constant, we can say that this is constant, then only this can be a 0. So hence we proved that. Thank you for watching video on in 5 minutes.